Well, there's a few ways that we have to know how to draw. The first one is called a perspective drawing, and we've kind of seen this before. Now, the way it works with perspective drawing, it really depends upon how many stereo or chiral centers you have. So, for example, we're not going to focus on cis-trans. We're going to focus only on chirality. So, for example, if I have, let's say, a system like this, well, this carbon right here in yellow, that has 4 different groups. Look closely. This carbon, let's say in red, it has an ethyl, right? It has this ethyl around it. It has a methyl around it. It has a Br. And then because there's only 3 bonds, it always should have 4, there must be an H as well, right? So there must be an H as well over here. Because remember, all carbons should have 4 bonds unless it's charged. And so if you don't see 4 bonds, you have to build it up to 4 with H's. Okay, so here's 4 unique groups. How can I draw this out? How can I draw a perspective drawing of this? Well, here's how it works. If you want to make a perspective drawing of this molecule, then you have 2 options. One is actually where we draw it, and this is the one I'm going to show now, which is called like a zoom in or a focused in point of view, a perspective point of view, where we're going to draw out the exact position of the chiral carbon and make it our focus. So here's a carbon that's chiral. It has 4 groups around it, which is a solid bond, a wedge, and a dash. That's how you draw right now as one point of perspective. So we're focusing in on the carbon that's chiral in yellow, and we're drawing all 4 bonds in the proper stereochemistry. So wedge means that it's coming out. Dash means it's going back. A dash means back. So this is a dash. This is a wedge. And then always there's 2 solid bonds, meaning those 2 bonds are on the plane of the page. So if you take a molecule and you build it up, you're going to have it where always 2 bonds can touch your hand at the same time, while the other 2 are going away and back behind your hand. Okay, so that's like, these are the ones that are sitting on the page. This is coming out to us, and this is going back behind the page. So by using a perspective drawing, I would fill in my pieces. So here's my little template, if you want to consider it that way. Here's the template right there. And if I use this template, the way it works is I draw out and I fill in my pieces. Now, it doesn't matter where my pieces go. I can put my methyl, which is 1 carbon, on top if I want, or below. It doesn't matter. I could put the 2 carbon side, the ethyl, I could put it here like that. Okay? Then I could put my H on the left or the right. It doesn't matter. And my Br on the left or the right. It doesn't matter. So you can plug this in however you feel comfortable. It doesn't matter. But here's the thing. This is only one of my perspective drawings. But of course, there's another one. There's the mirror image of this. So how would I draw the mirror image? Well, you always start with the skeleton. So the carbon in the middle looks like this. It has a carbon. Now, notice that whatever's vertical is still going to be vertical. So this is a mirror. And so whatever's up and whatever's down is going to be the same thing, like that. But notice that if this is a solid bond on the right, the mirror would be on the left. So whatever's on the horizontal is opposite. So now it's on the left. And if this is back on the left, now it's back on the right. So there's a back bond like that. So that's the mirror of the skeleton. And then just fill in your pieces. So up above is a methyl, so here it is. Down below is an ethyl, here it is. On the right is a H, so when it looks in the mirror, it's going to be on the left, right here. And on the left is a Br, so when it looks in the mirror, it's going to be all the way over here on the right, Br. And that's the mirror. So here, notice that what I did is a perspective drawing. I took this molecule and I focused in specifically on the carbon that's chiral. And I just filled in everything around it. You see that? Now, it doesn't matter how you put in your first set of groups. I could have put it however I wanted, just mirror it afterwards. Because let's say I put the methyl here and then this one over here. All you're doing is kind of spinning it in space. You're just flipping it around. That's not really changing anything. Okay? So just realize that that's how this works. So this is an example of what's known as a perspective drawing. Another type of drawing is called a sawhorse. Now, a sawhorse drawing is one that we use when we don't want to kind of blow up the one carbon that's chiral, and we actually want to kind of illustrate the whole chain. So a sawhorse is something we're really comfortable with from the first exam. It's like if we draw this right here, then we can just kind of keep it as we just drew it out. The zigzag, see, this is the same thing as up here, right? But notice how I'm blowing up the pieces around that central carbon that's in yellow, that's right here. But in this case, I'm leaving it as is. And all I'm going to do is I'm going to make this wedge, and then I'll put, you don't even have to show the H, but it's in the back. I'll show it now. And then I would make a mirror of this. So what would be the mirror? Well, always think about the skeleton first. From left to right, it goes up, down, up. So I'm going to do the opposite. I'm going to go down, up, down. That is the mirror. Notice how this is the mirror of that, and that is the mirror of that. So if I color, this is red, there's red. Here's green, here's green. Here's blue, there's blue. And then the end is yellow, there's yellow. Okay? Right there. So you see how that's complete mirrored? Now, if you draw a mirror like this, this is kind of laying everything out. If you draw a mirror, then you have to keep your wedge, whatever it is to begin, the same here. Wedge. And whatever's back is still back. I want to tell you something. If you put the back on the left or the right side of this wedge, it will not make a difference. But we'll learn about that in the next section, not now, when we name these things. For now, I'm just going to make it exactly a mirror like that. So there's the mirror. Notice that when this looks in the mirror, whoops, when this molecule on the left looks in the mirror, it's going to see the molecule on the right. Do you see that? It's perfectly mirrored up. The fact that it's a sawhorse is because I'm showing a full skeleton. Now, I want to point out something. So the perspective, a zoom in of the carbon, let's write that keyword. It's a zoom in of the carbon that's important to us, the chiral carbon. Whereas sawhorse, we're not zooming into the carbon. We're drawing it in this zigzag point of view, but we're just blowing the wedges and dashes up on the carbon that is most important. Notice I don't draw a wedge here, H, and a dash. We don't have to. Why? Because it's not chiral. If the carbon's not chiral, you really don't have to show wedge and dash. Sometimes teachers do that to trick you, to make you think that it's chiral, but you don't really have to. You only have to show wedge and dash when it's a chiral carbon. So this has the same exact groups. It has two solid bonds, a wedge and a dash. Now I want to show you another way to do this. Here's an alternative. Here's alternative way. Now this is also important because you need to know both. So either you draw a mirror, or you might want to just keep it like this, wedge and back, BR and H. And instead of drawing the mirror, I want you to see something. See, the fact that this red carbon is on the left and here it's on the right, that makes it a mirror. But what if I kept it the same skeleton? What if the red carbon, it's still on the right, and what do I have next? Green and then blue. So green, green, and blue, blue, right? So what if I left it the same exact position to the right? Then another way to show the mirror image without drawing an actual mirror is to reverse the groups that are wedge and dash. So if instead I took a wedge and instead of BR I make it H and back is BR, I am guaranteed that these two are mirror images. These are also mirror. They just don't look like they're a mirror because I'm not making it drawn out like that where it looks like a reflection. So you have to choose which way you want to do this, or if they're giving it to you, you have to realize this. You could either keep the skeleton exactly in the same direction, the red's on the right, red's on the right, and just switch wedge and dash, and that's going to be the mirror image. See, if I take this right here, and I was to flip it like a pancake. See, I can't do that in this tool that I have. Let me see, maybe I can. Yeah, I could. Here, if I flip this, well, actually, no, it's not going to let me do it because it doesn't know to reverse the groups. Let me go back. If I was to take this and put your hand flat on this paper, on this video, and flip your hand over, so your thumb, let's say you use your left hand, make it so that your left thumb is pointing to the BR direction, to the right. And now flip it over like a pancake, your hand. Notice that your thumb goes from to the right, it goes to the left, right? So if I was to take this and I was to flip it, then whatever's back